Hey gang, here's part 4 of our video series on how we built our backyard hockey shooting pad. The last video described the process to build the foundation of the platform. In this video, I'll provide a walkthrough of how I built the frame and the subfloor upon which the shooting tiles were laid. We'll talk about the materials and tools used and also the lessons that we learned along the way. Let's get to it. Alright, the second phase of the project was to build the frame and the subfloor. This phase required building a rim or a frame around the platform to attach the floor joist to. So I started by measuring the length of the long and short side rim joists needed, and I cut them to size. In my case, I needed two 2x4x12 pieces of lumber to span the 21.5 feet long side of the platform. So once again, I used the butt-to-butt technique to join the two pieces of lumber together. Check out part 2 of the video series, which references this technique, and the video that I found on YouTube that explains it. The purpose of the joint is simply to attach the lumber together. There's no load being applied to the joint since it's sitting directly on the skid. I would never use this type of joint for any load-bearing workload though. But in this case, it's been fine. With the rim joists all measured and cut, I then proceeded to fasten the long side rim joist to the short side rim joist together using 2 galvanized framing nails at each corner. Next step was to square that frame that I just created that was sitting on top of the platform by measuring the diagonal corners and ensuring the measurements were identical. So once that frame was squared, I installed 1 countersunk lag screw and washer at each corner of the frame to fasten the frame to the skids below to really add some stability. The process of pre-drilling these required 2 steps. The first step was to use a 1-inch speed bore drill bit to create the countersink, which allowed the lag screw and washer to be installed without impeding the subfloor that's going to then sit on top of it. And the second was to pre-drill the hole for the lag screw. I got this tip from YouTube and it worked very well to secure the rim joists, that frame, to those skids. The lag screw was tightened using a ratchet and socket step. This step was pretty simple overall. It only took me a few hours to complete, but securing that frame to the skids is really important, and I have to say, using this technique, it is quite secure. That frame's not going anywhere. Alright, so there's a lot to talk about here when we start talking about the floor joists, so let's get into it here. With the rim joist securely in place, the next step for us was to install the floor joists. And one of the great attributes of this design was that the floor joists would rest and transfer load to the skids, which avoids having to purchase and use what's called joist hangers. The design that we're using, it's a very solid design for this type of application. And here's what's involved. So the floor joists need to be installed 16 inches on center to ensure that the subfloor, or the plywood, would have equal support and that all edges of the plywood would sit on top of floor joists that we could then screw into. This is a crucial step in making sure that the subfloor was going to be installed properly, so great care was needed not to mess things up here. So the first step was to measure and mark both long side rim joists to indicate where each floor joist would be positioned. We then measured, cut, and positioned each floor joist with the crown facing up, one at a time. Important note here, before fastening those floor joists in, I laid down a few sheets of plywood to test the placement of the floor joists and make sure they were in fact 16 inches on center. The length of my platform, in my case, could not accommodate every joist being 16 inches on center, so I had 1 floor joist at one end of the platform that was slightly less than 16 inches away from the rim joist. For our application here, this did not affect any of the other floor joists, which were 16 inches on center, and it did not prevent the plywood from sitting properly on the floor joist. Just something to keep in mind when planning your project. We then proceeded to fasten the floor joists to the rim joist by hammering 2 galvanized framing nails on each side of the floor joist. Without a nail gun, I have to say this required quite a bit of time and precision. Some of the nails went in smooth, others started bending and required more finesse. And also, once the ends were fastened, we then proceeded to toenail the center of the floor joist to the middle skid by hammering 2 nails, one on each side of the floor joist, diagonally into the middle skid. This technique here prevents any kind of movement or bounce of the rim joists against the skids, which provides for a quieter and stronger frame. This was a fun part of the project, and you could really see the platform coming together when this part was done. Okay, so with the frame and floor joists now installed, the next step was to install the subfloor, which was pressure treated plywood. So using the design, I had calculated that I needed 9 sheets of plywood to complete the floor, and that's exactly how it ended up. The process is relatively straightforward here. I started at one corner of the platform and laid down the first sheet, making sure it was well positioned before fastening it down. Once it was well positioned and that I confirmed that the short side edges were sitting on a floor joist, I then proceeded to measure and mark the locations where I needed to screw the floor down. You'll see in the time-lapse video that I used my level for this purpose. With the locations of the screws identified, I then fastened the plywood down using stainless steel wood screws. The pattern that I use was 6 inches apart on the perimeter and 12 inches apart in the field, which is plenty strong and pretty standard out there. I know that you can use construction glue to further avoid squeaks, but I decided to avoid using such products because it's a shooting pad and we will eventually tear it down, and I figured the glue would make that process really difficult. PL is very strong stuff, and I want to be very careful about using that, and it just wasn't necessary in our case. So once the first sheet was fastened, we continued to lay down the sheets one column at a time, leaving about 1/8 of an inch of space in between the sheets for expansion. The third sheet in the pattern needed to be measured and cut to size, which I did using a circular saw. It's important to stagger your columns of plywood so that the second column was started where the third sheet left off, which naturally created a staggered pattern, again to improve stability and strength. Check out part 2 of this video for a view of the plywood layout that we used. We then repeated this process until the entire platform was covered. The third column of plywood was too wide for the platform, and each piece in that third column needed to be measured and cut to fit. Ideally, if I had unlimited space, I would have configured the dimensions of the pad so that I could avoid these cuts, but I had to use odd dimensions to fit the space that I had. The toughest part of this step was screwing down the subfloor. As I've mentioned before here, my low-end cordless drill's battery kept dying because of the load and the cold. So about halfway I borrowed a corded variable speed drill from my neighbor, which is a much better tool. The other caution is to be careful when drilling. I used square drive screws and 99% drove well, but the odd screw would strip if I pushed it too hard. So be careful when drilling not to strip the screws. If I did strip one, I had to use vice grips to unscrew it and replace it with a new screw. Okay, so with the subfloor in place, I then proceeded to install the sideboards around the platform, which would help keep the pucks on the pad. I used pressure treated deck boards that are 2 by 6 inches wide for this purpose, which worked well overall. But a few notes about these. First, due to COVID-19, I had to order these online, and the batch that were provided were not straight at all, unfortunately. So I had to do my best to position the worst boards against the shed or fence to hide these imperfections. If you can, make sure to go to the warehouse and check all lumber before purchasing. Second, the height of the boards is okay. They stop most pucks, but I've noticed that if a puck is rolling or ricocheting quickly, some of them go overboard. A few more inches higher would prevent this problem, but overall they work as intended and also help to give the platform a finished look. The process for installing these was very simple. Measure and cut to size, and I use galvanized framing nails to fasten them to the skids. I have noticed that the boards have moved a bit away from the skids since installing them. Maybe the kids are pushing off on them while using the pad, so I'll be reinforcing the nails with screws to prevent the boards from lifting. Alright, here are the materials that were used for this phase of the project. The rim and floor joists were constructed using 21 12-foot long pieces of pressure-treated 2x4 lumber. The floor was built using 9 sheets of pressure-treated 3/4 inch 4x8 plywood. We used galvanized lag screws and washers to secure the rim joist to the skids, and galvanized 3.5 inch framing nails to secure the floor joist to the rim joist and skids. The plywood was fastened using a combination of stainless steel number 10 3-inch square drive screws on the perimeter and 2-inch screws in the field, which worked very well. We also used the same galvanized framing nails to secure the boards to the skids. This is a list of all the tools I used for this phase of the project. As you can see, most of these tools are common household tools. Once again, I'm not a carpenter, so the tools that I have are pretty medium to low end, but they did the job, with the exception of my cordless drill, which did not work very well at all. And I ended up using an electric variable speed drill, which was fantastic for screwing down the subfloor. Okay, so lessons learned on this phase of the project is to measure twice and cut once. Planning was key to make sure that each step supported the next. Any mistakes here will cost you time, money, and multiple trips back to the hardware store. I found that laying down the rim joist first and testing the location of the plywood really helped to confirm their placement before nailing them down. Also, toe nailing the floor joists added a lot of stability to those floor joists. Marking the screw locations was also very helpful in making sure each screw was biting into the floor joist underneath. The electric drill saved the day by not having to worry about charging its battery or the cold affecting its charge. And finally, I can't say enough about this, but make sure to use the right fasteners for the job. You'll notice that we use galvanized nails and lag screws and stainless steel screws. All match the spec provided by the manufacturer of the pressure-treated wood, and all have been designed to resist corrosion from the wood and from the weather, so be careful about that. So that was an overview of the process used to build the frame and the subfloor of the backyard hockey shooting pad. If you're interested in learning about other phases of the project, please check out the other parts of the video. I really hope this was helpful, and I wish you all the best with your project.